Hello, this is video 4 for Chapter 9, STA2023 Statistical Methods. So in this example, we're still doing a t-test difference. It's still a t-test, but notice this time we have data. So in an effort to better serve the needs in our community, Valencia College would like their employees to take a course on how to speak Spanish conversationally. This is called Hola Amigo. That says their Spanish course improves people's ability to speak Spanish. Valencia decided to send 15 randomly selected representatives to take the course to see if it improves their ability to speak Spanish. Below are the results of a pre- and post-test. The pre-test was given before the course, and a post-test was given after the course. Is there a statistically significant difference in the results? Was there improvement post minus pre-test? The highest on the exam is 50. So let's make sure we understand what's going on. We're not going to send everyone at Valencia College to take this course. We're going to find out if it works. So we send a random sample of 15 people. We give them a pre-test. The same people take a post-test, and we want to see how they're doing to see if there was improvement, if their score went up. Again, we're going to do post minus pre. So I'm going to go to my calculator, and I'm going to go to stat number 1 for edit, and I put all the pre-tests in list 1. I put all the post-tests in list 2, and I double triple check your numbers are okay. But I don't want the pre-test and I don't want the post-test. What I want is the difference between them. So in list 3, I'm going to move it all the way to the top. Make sure you're on list 3, on L3. And what you want that to be is second 2 for list 2 minus second 1 for list 1, which is post minus pre, as it says in the instructions. Press enter, and again, make sure you did it up there. All the differences, 37 minus 35, 2, 20 minus 25, negative 5, are all here in list 3. So what we're looking at is the differences, which are in list 3. Differences in list 3. So we'll go back to the notes, and we'll fill in our HO and HA. So remember, we're talking about difference, and the HO would be that there's no difference. Mu equals 0. The average difference in test scores for Valencia employees, post minus pre, after the course is 0. No difference. We want to see if it improves, greater than. The average difference in test scores for the Valencia employees, post minus pre, after the course is greater than 0. There is a difference, greater than 0. So there's your HO, there's your HA, but again, we need some information. We need to find the X bar, S, and N of the difference list. So remember how to do that in the calculator. Start at the home screen, second mode, from the home screen, stat, to the right for calculate, number 1 for one variable statistics, list 3, press enter, X bar 2.67, S 6.81, N 15. Those are the numbers we'll be using. So it's random. We don't have greater than 25, we only have 15, so we'll go ahead and assume it's normal. If you make a histogram of this, this is what it looks like. It's about normal. It's not perfect, but again, you want to have more than 25. But we'll just assume it's normal. We'll let it pass. And then we're going to do our SE. Standard deviation divided by square root of n. 6.81 divided by square root of 15 gives us an SE of 1.76. T is 2.67 minus 0, x bar minus mu, over the SE, 1.76, gives us a T of 1.52. Then, to find T star, because alpha is 5%, our confidence is 95%. Degrees of freedom is 15 minus 1, which again will go to the table. So at the table, we go to 95 and 14, which gives us 2.145. That's where our T star comes from. So picture-wise, using critical values, our T is 1.52, so it'd be about here, looking for more than. That would be a picture of our p-value. Our alpha is like our T star, 2.145, and that to the right would be a picture of our alpha. Notice our P is not smaller than our alpha. But again, we can get that p-value from the calculator. So to do that from the calculator, we go to stat, tests, t-test, but this time we have data. You could also do stats if you put the numbers in, but we did data. Mu is 0. Our list is list 3, the difference list. Frequency is 1. We're looking for greater than. You can just calculate or draw. If you go to draw, we're going to get our T, which up here we got our T as 1.52. And see if we match our p-value. It's going to be close, but it could again be a little off because we're rounding when we do it by hand. So our T is 1.52. Our p-value 0.0758, 0.0758. So we compare our p-value to our alpha. P-value is 0.0758, which is larger than our alpha of 0.05. So, we're using two different levels here. So we're using 10% and 5%. I did this on purpose so we can practice our conclusions. So if the alpha was 10%, the p-value is smaller. 7% is smaller than 10%. We reject HO. There is statistically significant evidence to reject HO. We conclude that the average difference in test scores for Valencia employees post-pre is greater than 0. So again, if alpha was 10, our p-value is smaller. This is 7%. This is 0.10. If it's smaller, we reject HO. There is enough evidence, and it is greater than 0. But for practice, I gave you two alphas. If alpha was 5%, like it in the picture, then our p-value is not smaller. So this is 7%. This is 5%. This is 0.05. This is 0.07. In this case, the p-value is not smaller than alpha, so we do not reject HO. There is not statistically significant evidence to reject HO. We conclude the average difference in test scores for Valencia employees post-pre is not greater than 0. So this is a good example of writing a rejection and a do not reject. So you get to see both. Now it depends on your alpha, remember? It's your p-value compared to alpha. So we have both here for practice. So when we do our confidence interval, we're going to go ahead and do both. So at the 90%, the only difference is our t-star. So if you go to the table, which we've done before, look up 90% and 14, you get 1.761. And we already looked up 95% and 14, which gives us 2.145. That's the difference for the intervals. So at 90%, we get negative 0.043, 5.77. And at 95%, we get negative 1.1 and 6.45. Now, just to make sure we clarify, at 10%, we said it's greater than 0. Well, if it's greater than 0, it should be two positives. And when we did the interval, we did not get two positives. We got a negative and a positive. But let me explain why. This is on the edge. How much of it is actually negative? Not even a point. Not even half a point. So sometimes it falls on the edge, but we still say it's greater than 0. So notice in the write-up I put 0 because it's rounding off to 0. But you can still put the negative. But the idea is that slight amount is negative, so we still say it's greater than 0. So we are 90% confident the average difference in test scores for Valencia employees post-pre after the course is between 0 to 5.77 points higher. Both positive, higher positives. Now at 95%, we definitely have negative a point and positive 6 points. So we would say we are 95% confident the average difference in test scores for Valencia employees is between 1.1 points lower, negative lower, to 6.5 points higher, positive higher. Now, you may be a little confused saying, it's not really that much of a difference. And overall, if you look at it, it's not. You could go up maybe 5 points, but you could stay the same at 0. Or you could actually go down a point and go up at most 6 points. So overall, looking at this, and that's the critical thinking part, I don't think it's worth going. And that's why we do this. Now, remember, 95% is stricter than 90%. So that's why 95% is usually our standard, 5% alpha, 95% confidence, and it has that negative in there. But again, overall, I would say that it's not worth going to this Spanish workshop to help improve the Spanish ability. But what's good for you in this example, make sure you remind and refresh with this example, you get to see both conclusions when you compare the p-value to alpha.